Right. So simultaneous equations then. Basic technique. Well, there's different ways of doing it. So we'll look at what's known as the elimination method. So the first thing you want to do is eliminate a variable. Then you go and solve it for the other variable. Then substitute back in and go and work out what the eliminated variable is. That's the basic idea. What does all that mean? Yeah, these sorts of things are what we're talking about. Anytime you've got the same number of equations as you do pronumerals, it should be possible to find the value for each of those pronumerals. Unless, of course, the equation is just a multiple of the other one. Which one would I have eliminated? You basically want to make the coefficient of one of those the same in both equations. So, what did I do? I've decided to multiply the first one by 2 and the second one by 3. So I'm going to make the coefficients of y the same. So I end up with 4x plus 6y is 42, 15x plus 6y is 9. So I can subtract, get rid of the 6y's, it's eliminated, very simple equation to solve. X is negative 3, so that's step 2, solve for the other variable. Substitute back in, and we get y equals 9, so we have our solution. Now I don't just leave my solution like that, I should make it definite what my answer is. So I write a concluding statement, well therefore x is negative 3, y is 9. Okay, then you get ones like this where I can't really do it that way, because whilst those pronumerals look the same, they're not actually the same, because you've got y and y squared, they're different things. So this one here, we do this way. I'm going to make y the subject in the first one. So y is 14 minus x. And then I'll substitute that in to the second one. This is known as the substitution method. It creates a quadratic equation. There's the factorization, 3x minus 41, x minus 5. So we have two possibilities for x. Logically, it means we're going to get two possibilities for y as well. So we'll substitute in to get those possibilities. Now this is where it's really important to write a conclusion, because you need to know which one matches up with which one, and it's not really clear with what I've written down so far. One possibility is that x is 5, y is 4, nice neat solution. The other possibility, not quite as neat, x is 41 on 3, y is negative 40 on 3. So two distinct possibilities. Now I said any time you've got the same number of equations you do pronumerals. Sure, most of the simultaneous equations you've seen so far are just two equations. But you can use this idea. Here's one where I've got 3 equations and 3 pronumerals. A few more steps, but the idea is the same. I'm going to eliminate one of those variables, but you do them a pair at a time. So I'm going to create 2 new pairs. First of all, I'm going to multiply the first equation by 2 and match that one up with equation number 2. The coefficients are the same for the x values there. So I can eliminate the x's. So I got 7y minus 6z. Now I pick another pair and eliminate the same variable. Now I'm going to multiply the first one by 4 and match that up with the third equation. Again, I can eliminate the x's and I get these 2 new equations. But now I've got 2 equations, 2 pronumerals, what we're used to seeing. Alright, so now I'm going to solve these ones simultaneously. I'm going to multiply the second one there by 6, so the z's are the same now. Do a subtraction. Okay, I know what y is. And now all I've got to do is work backwards and I can get the others. So I can substitute back into, well, either of these 2 equations and get z. Z's 4. Now I know what z is. I can go and work out x. Substitute that into one of the first equations we had. X is 3. So I got my final answer. X is 3, y is negative 2, z is 4. And as I say, you could have 4 equations of 4 pronumerals. There'd be a lot more steps involved, but you just keep knocking off one of the pronumerals at a time till you get it down to 1 pronumeral, work it out, then you go back the other way and you can work out all of the pronumerals.